Looking at section 2.5, zeros of polynomial functions, we are going to break this section into 3 days. So for today, we are going to look at use the rational zero theorem to find possible rational zeros. In the last section, we looked at a graph that we were able to identify a solution of the graph and use our synthetic division to start breaking that problem down to find the other solutions. What the zero or the rational zero theorem is going to do is it's going to help you find a way to, by looking at the equation, start determining possible solutions that we'll then use to test to find which ones are solutions. Number 2 says we're going to find zeros of polynomial functions, very similar to what we've been looking at. In tomorrow's lesson, we will look at solving polynomial equations, and then the third part, we will use the linear factorization theorem to find polynomials with given zeros, and then use Descartes' rule of signs. So let's take a look at the first part. The rational zero theorem, if we have our polynomial function, and it has integer coefficients, and p over q, or p divided by q, where p over q is reduced to simplest terms, meaning the simplest fraction you can make, is a rational zero of f, then p is a factor of the constant term, a sub 0, and q is a factor of the leading coefficient, a sub n. What does that mean? Well, we are going to take and look at the fraction p over q. So if I were to look at p divided by q, what is that? The p, it tells us that p is the factor of the constant term a sub o. So that means we are going to look at our factors of the constant term, right? That constant term a sub o. So we're going to be looking at the factors of that last piece, and we are going to divide it by the q, it tells us, is the factor of the leading coefficient a sub n. So that means we are going to look at that a sub n to figure out what that q piece is, which are going to be our factors of the leading coefficient. So the rational zero theorem tells us that we are looking for p over q. We want to find all the possible solutions of this polynomial function. Now, if you remember all the way back to algebra 1, and you would have had something like an 8x squared plus a 3x minus 5, you would have looked for all your factors of 8. You would have looked at all of your factors of 5 to try to figure out if you could factor it. Well, we're kind of still doing the same thing. The difference is once we find the factors of the constant term, we are going to put those on the top of the fraction. And then we're finding the factors of the leading coefficient, which is the factors of the leading coefficient, which is the bottom. So we're doing something very similar to what you've already done. You're looking at those factors, but we're going to take them and write them as a ratio, a comparison. So we're going to have the factors of that constant term divided by the factors of the leading coefficient. So let's take a look at an example. So it says to list all possible rational zeros of, we have f of x is equal to 4x to the 5th plus 12x to the 4th minus x minus 3. So you're going to find your constant term and your leading coefficient. So it says that the constant term is negative 3, the plain number, and the leading coefficient, the highest powers coefficient, in our case is 4. So our factors of the constant term is negative 3, and the factors of the leading coefficient are 4. Let's break those down. So if I were to look at my negative 3, I'm not going to worry about positives or negatives. I'm just going to look in terms of what would make a 3. So what times what makes a 3? Well, in order to get 3, the only way to make 3 is a 1 times a 3. So that means the factors of the constant term are going to be a positive or negative 1 and a positive or negative 3. That's how we'll figure out in terms of our sign. And then if we look at that constant term, how do we make a 4? Well, we can make 4 by 1 times 4 or 2 times 2. That means we're going to have a positive or negative 1, a positive or negative 2, and a positive or negative 4. No need to repeat that number 2 because 2 times 2, it's just 2 is a factor. So then what we want to do is we're going to take all of our factors of negative 3 on the top and all the factors of 4 on the bottom, and we're going to write out all the possibilities. So we are going to look at taking that positive or negative 1 and that positive or negative 3, and then we're going to divide it by our positive and negative 1, our positive and negative 2, and our positive and negative, not 3, 4. Got carried away, 1, 2, 3. All right, so what we are going to do is we're going to break down all of our possible fractions. So if you think about it, let's start with this positive negative 1. I'm going to have a positive or negative 1 divided by my first possibility is a positive or negative 1. Well, 1 divided by 1 is a 1. So that means we're going to have a positive or negative 1. Let's look at the next option. Sticking with this positive or negative 1. I have positive or negative 1 on the top. And what else do I have on the bottom? A positive or negative 2. That means I'm going to have a positive or negative 1/2. Stick with our positive and negative 1. Our last piece that we have on the bottom is positive or negative 4, which means that we could have a plus or minus 1/4. I took care of all the possibilities with 1 on top. Now I need all the possibilities with 3 on top. And guess what I'm going to do? I'm going to do the same thing, but I'm going to put a 3 and a 3 and a 3, and let's see what we have. If I have a plus or negative 3 divided by a plus or negative 1, that's going to give us a plus or negative 3. If I have a plus or minus 3 over a plus or minus 2, that means we have a plus or minus 3 over 2. And I have a plus or minus 3 over a plus or minus 4. So I have a plus or minus 3/4. Now, all the possible solutions of this polynomial, how many do I have? I have plus or minus 1, plus or minus 1/2, plus or minus 1/4, plus or minus 3, plus or minus 3/2, plus or minus 3/4. So that means I have 2, 4, 6, 8, 10. There are 12 possible solutions to this problem. This is why we learned our synthetic division, because as we get better at our synthetic division, it's a lot easier to do multiple synthetic divisions than it is to try to do long division multiple times. Okay, so we're not going to use this example to continue breaking it down and try to find the solutions. We're going to do a slightly easier one. But if they ask you just for the possible rational zeros, those are the possible rational zeros. Now, to be able to take it to the next step, they want us to find zeros of the polynomial function. They want us to go through the whole process. So we're going to find all the possible solutions like what we just did, but then we're also going to take it a step further. We're going to use that synthetic division to find the actual solutions and break it down. So it says to find all zeros of f of x is equal to x to the third plus x to the second minus 5x minus 2. So it says we begin by listing all possible rational zeros. So again, we're going to take our constant term. How do I make 2? Well, that's a 1 times a 2. My leading coefficient here is just a 1. Well, how do we make 1? The only way to make 1 is 1 times 1. So remember, we're going to take all of our constant value factors divided by our leading coefficients, so our P over Q's. That means we're going to have a plus or minus 1 or a plus or minus 2 over top of that plus or minus, all I have is 1. I have 1 possibility for that leading coefficient. That means I really have that plus or minus 1 or a plus or minus 2. This is only 4 possible solutions. So this one's not bad. The 12 possible solutions, that could end up being a lot of work if you don't find a solution right away. Okay, so it says now we use synthetic division to see if we can find a rational zero among the 4 possible rational zeros. So we're going to take it to some synthetic division. So we found out our possible values. We had plus or minus 1 and plus or minus 2. So that means we have a positive 1 or a negative 1. We have a positive 2 and a negative 2. Those were our 4 possible real zeros or rational zeros. It says we will use synthetic division to test the possible rational zeros. Now, as soon as you find one that is a 0, you're done. So let's start with 1. The first one I had was 1. Let's try 1. So I already have kind of my stuff set up here in terms of my synthetic division. Hopefully you remember that this was the 1, this is a 1, this is a negative 5, this was the negative 2 where all those numbers came from. So we drop down our first 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 5 with 2 is a negative 3. Negative 3 times 1 is a negative 3. I have a remainder of negative 5. Is that a solution? No, right? It has to be 0 for it to be a solution. It has to go in evenly. Let's try negative 1. So if I try -1 again, and if you want to erase what you just did and try again, you can do that, right? So for some people, that might be easier. 1 times a -1, that's a -1. That leaves us with 0. 0 and -1 is a 0. That leaves us with a -5 times -1 is a +5, which I could already tell is not going to give me what I'm looking for, right? At some point along your synthetic division, you might be able to say, nope, that's not going to work out. All right, so that's not going to work either. Let's try the next one, +2. If I try a +2, let's break this down. 1 times 2 is 2. 2 with 1 is 3. 3 times 2 is 6. That is a +1. 1 times 2 is +2, which gives us, we found a solution. I got 0 left over. That means that +2 is a solution. That is a real 0. So we have found a rational 0 at +2. I didn't even need to check the -2. If you want to, go for it, but see what happens, right? If that works out, you can use that one. So some of you might get one answer in the first step of breaking down that synthetic division. Some of you might get a different number if you end up with multiple solutions found easily that way. So let's see, continuing on. So we have found that we had a solution at +2. And when we went about using that +2, which I can just kind of recopy what I had a 1, 3, 1. That was what was left over, right? We had the remainder of 0. So that means if I had, my highest power was third power, or I guess I could just call this my constant, and then that's going to be a 3x, and that's going to be a 1x squared. This is a positive, that's a positive. So when we started breaking this down, we found that 2 was a solution. So if x equals 2 is a solution, that means that x with what was equal to 0. This is going to end up being an x minus 2 is equal to 0. So we have an x minus 2, and we are left with an x squared plus a 3x plus 1. All right, so all I did is kind of work backwards to get to what that was. So it says we now solve. So I want to see if I take an x squared plus a 3x plus 1, can I solve by factoring? Well, the only way to make a 1 is a 1 times a 1 and an x times an x, and that's not going to work out. I'm not going to get a 3 in the middle. That means I need another means for simplifying down. It's a quadratic, it's a second power. So since factoring didn't work, I don't think I really feel like completing the square, but maybe I'll just take it to our quadratic formula, because that's should be fairly easy at this point. So we found, again, some of this is repetitive, sorry, x minus 2 and an x squared plus that 3x plus 1. So let's go ahead and use that quadratic formula to figure out what the rest of our answers are. So if I have an a value of 1, I have a b value of 3, and I have a c value of 1. We have our negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully that's still in your memory somewhere. So the opposite of b, so negative 3. And then we're going to have plus or minus our square root of b squared, our b value 3 squared minus 4 times 1 divided by 2 times 1. Simplify down, negative 3 plus or minus, let's see, we have a 9 minus 4 times 1 times 1, 9 minus 4, square root of 5. And 2 times 1 on the bottom is 2. Well, we're not going to take it all the way down to decimals. Decimals are really not an exact answer. An exact answer is a simplified radical. So that means we already found we had one answer up here. If x minus 2 was that one solution, we had that positive 2. We had already found that solution. And now we have a negative 3 that's being added with root 5 over 2. And we have a negative 3 that's going to subtract the root 5 over 2. So those are our 3 solutions that we ended up finding.